This conference will now be recorded.
So thanks everyone for coming. Again, my name is Ratikant, and I'll go over the details, in regard to my profile and what do I do. Then with me I have Vijay. Same Vijay? No. Okay. Okay. All right. We were talking about you earlier. So Vijay Ramchandran. My name is Ratikant Pratap Singh, and I go by the name RP. You'll see that in my next phase over here. What's going on? Okay, thanks. Where is this? Drag it. Yeah. Doesn't go. Minimize this. Hold on 1 second, guys. Try to drag. Use new hardware. Use new hardware. Yes. 1 second, guys. Okay. All right. Maybe it is. Okay. Let me just shut down the door. So myself and Vijay, we are here, and as I said, we just to give a bit background, I have been training big data for last 3-4 years since 2014. Over last year, we started looking at where the technology is going. Right, we focused on more on the cloud side, and that's where we specialize on AWS, and we have planned to go into Azure next year and GCP. These are the three, I would say, main vendors in the cloud space. So, but of course, AWS is the dominant player. So we are going with that. And when you come to cloud, we have two different. We'll talk about the two different streams or two different tracks, right? We cover. One is cloud platform engineering, right? We'll go over that detail. Visual go over that detail. Second one is the cloud data engineering. Right? If you look at what's happening in the industry, as I discussed a little bit 5 minutes back, right? The on-premise applications, whether it's simple data storage, we call it data lake, right? Enterprise data warehouse, people used to have big data warehouses and all that, right? Right, I have been working for many years. Typically, what other use cases? Other use cases like reporting, right? In traditional, we have been using Tableau, Cognos, business object, MicroStrategy, all that stuff, right? The typical reporting application, which every Fortune 500, Fortune 5000, if you go there, that's the measure work. You go there, they will have a data warehouse, data mart, and some reporting. 90% of the work, if you see that, right? Of course, then the new use cases that's coming up in the last several years, advanced analytics, machine learning, AI, all that stuff. In CVS, where I work on the enterprise analytics team. I mean, every project that's coming up new, most 90% of them are advanced analytics projects. And good thing is the platform is again either Azure or Atomlogs or Cloud. It's all the same platform, which we will be starting. So use cases, reporting use cases, your advanced analytics, AI use cases, you'll see more and more of this, right? You'll see more and more of this, and even your regular web servers and all that. That's where the cloud, EC2, all those things we'll talk about that. Those generic applications, those are also moving to cloud. What I'm trying to say, right? So looking at where we are at, right, in terms of industry adoption, right? What is changing is your platform, right? Right. So platform is changing. Instead of putting everything in my data warehouse, in my on-premise, big what do you call all that to cloud, right? Few years back, yes, people are a little bit hesitant to put things in cloud. Now they're getting more and more comfortable. You see that, right? That's happening because of regulation, regulatory things and all that stuff. But things are getting more and more secure. That you see that. But in general, if I summarize, data it's the whole industry is now data driven, right? If you think about any business use case, data driven, right? More data you have, you say you are more rich, right? That's the data is the new oil of 21st century, they call it, right? So anyway, so it has to be data driven for you to be successful, right? In fact, just for reference, we are with CBS, we are starting a new project which is called pharmacy advisor personalization. This is 15-year-old application, which was which patients do you call, how to engage with them, and you have diabetes, you need to do this. This is a typical counseling, right? This was all based on rule, not even rule based. They send out mails and everything to everybody. It was not personalized. Now we are changing that application. We're starting in fact this week. I just got engaged on that. By next year we are completely migrating that application to machine learning based, right? Recommendations, personalize which channel, what kind of content, and what time you need to deliver, so that it is the patient feels yes, it is for me, right? The whole personalization thing, right? And this is happening industry everywhere, right? It's very common. So what I'm trying to say, it's data driven. It's it has to happen right now, right? It's the whole real time thing, the concept of real time and near real time. And so which are more process intensive, right? Need to be scalable. Big companies, you need to sending out mails or interacting with thousands of for example, CVS Pharmacy has 100 million patients. How do serve those many customers with agility, flexibility, and personalized, right? That's the goal every company is trying to achieve. So where it comes to the platform is key, a scalable platform. And if you can build it on premise, but if you look at the future, cloud is the future in terms of scalability, right? You don't have to acquire 100 clusters and pay for it if you are not even using it, right? But that's elastic. Whatever you use, you just pay for it. If you're not using it, don't pay for it, right? It makes sense from the economic standpoint, right? Economy standpoint. So that's the trend. That means platform of tomorrow, even today, is going to be cloud. They say by 2020 or something, 50% of the world's data will be on cloud. And whatever has happened in terms of data accumulation, right? The typical mobile, the social media, all that stuff, right? That's kind of creating the data deluge, I would say, right? The data is growing, almost doubling every 2 years. The world data is doubling. By 2025, currently I think we have around 20 zettabyte. By I think with 15 zettabyte or something like that, but within 3 years it is going to be 45 zettabyte. There's some numbers are there, but what I'm trying to point out is data is growing, right? That problem is not going to get solved. If you look at that, what's the right platform, right? If we are in IT, what should we do at this point to stay relevant to this technology, to this industry, right? Platform, which is the future. Of course, AWS, Azure, they are huge companies. They are here to, right? If they have invested billions of dollars, that technology is not going away, right? That is the trend, right? And of course, the use cases, AI, ML, those all that stuff, right? And AI, ML are reporting those kind of use cases. Where do they run best? On Hadoop, right? Primarily, if you look at Spark is one of the platform which we'll be talking about in a bit. That's where most of the use cases run, right? What language you should be learning, right? That's the question. So platform, which is your text comes with storage and all that. Then processing framework, a scalable framework like Spark, and language. What is the best language to go for? I know C++. Now Python is becoming very popular because of Python and Scala, of course Java, right? You can't be expert on all three if you are not expert, but at least speak a good language. What we cover in our classes, we make you good in Python, assuming that you have some basics of programming knowledge. And it's easy to learn. And fortunately, all this the cloud platforms adopt Python in a big way. And Hadoop is, which we cover Spark, PySpark and all that. That's the reason we go with Python in a big way. Although I used to teach Scala earlier. I mean, you can do both, but get good at one language. That's my point. So if you want to be relevant to the industry, to be good at where the industry is going, get good at one language, learn a good platform, which is AWS or Azure, and then learn the data engineering side of it. What I mean, like how to move around data, right? The platform engineering, that is how to automate the whole EC2, S3, EMR, all that stuff, right? And how to do the data movement. That's the data engineering comes in picture, where Python, Spark, Hive, the Hadoop part, right, comes in, right? That comes in picture. So one is a platform engineering, pure platform on cloud or on what you call AWS. Other one is the once you understand the platform, how do you do your data engineering on top of it, right? As a backend engineer, as a backend architect, right? To serve your reporting people, to serve your AI ML people, right? So that's what, based on our experience, 20-25 years, each of us, me and Vijay, right, we have worked in this field, done tons of consulting, consulted many different clients. So this is what the key is, right, for anybody to be successful in this area, and for even to survive, to be relevant for next 10 years, pretty much in this technology. I can't promise what will happen in 2 years, but still to be relevant, people, those are doing some Java stuff last few years, QA stuff, some basic Unix and all that. I think it is, or database DBA, all those kind of stuff. I think it makes sense to get good at the cloud, good at a platform like cloud, learn a good language which is going to be relevant, right? And do some data engineering if you want, you can do that, right? So that's why you have two different streams. What I cover is the data engineering side of AWS. I'll go into details, then Vijay will come and talk about the platform engineering side. Okay. Just to give some statistics, in the last 3 years, as you see here, last 3 or 4 years, I have trained almost 300 students in this building and some other way. I was, almost, I don't know, 15-20 batches. I have done almost more than 300 folks, and around, I won't say a lot, everybody has got jobs, but I think around 25 folks which I personally helped. I don't know beyond that. I'm not in touch with them who got and all that jobs, but 25 folks which I personally have helped getting the jobs in the at least last 2 years, which in the big data area and AWS area as well. This is my personal record, and I get a lot of references based on that, because the people I have placed them, they a lot of folks primarily from African community, to tell you truth. Cameroon, Nigeria, and all that. I've helped Cameroon, at least 15 folks I've helped getting jobs. So I get a lot of reference from Cameroon. Many of my students, I have, but anyway, of course, Indians as well. So now, that's my background. Now coming back to, we kind of talked about why AWS data engineering. Cloud is the platform of future. Many on-premise applications are moving to cloud. We all know that. AWS is the dominant player among all cloud vendors, whether it's Azure, GCP, and all that. AWS is one of the dominant player. And AWS with the big data is a great skill set for current industry needs, right? If you have strong in one of the cloud platforms with some data engineering, you are relevant. You can get a job anytime. Tell you can get anytime, and good money, good consulting needs. I know people. I have been one of our colleague with our company. He's in 20s. I mean, he does 2 jobs. One job, he works for Amazon, and he makes almost 200K, and he's doing a big data job on the side as well. Of course, he's young. He can work 24 hours a day. But people in 20s, making that kind of money. He has 6 certifications in AWS. 6 certifications. So of course, certifications are the key. I know you have done some certifications, right? So they are key. Absolutely. So those are key. Along with that, some industry use cases which we bring in from our experience. When you mix that, I think it's pretty powerful. Some data engineering, good platform engineering with some certifications, you are relevant for next 10 years, and it's a good money making, money making job, I would say, right? Typical AWS with the big data is a great skill set. In typical cloud use cases include, as I talked about, big data lake on cloud, reporting, advanced analytics, AI on cloud. These are the typical use cases you'll be working on, even though you don't have to be ML, machine learning, or AI expert, but it will be working on the back end to create that data for the data scientist to be using it, which I do in my profession as well. So that's why to learn AWS, or why to learn any cloud. That's doesn't have to be AWS, but that's what we focus. Okay. Any questions so far?
The cloud is the platform of the future.
cloud is it's not future because they say like future is here, right? So it's already there. I mean, I see most of the Fortune 500, they are willing to, they have started moving. They have started moving. I'm talking about CVS, and we merged with Aetna. CVS had a its own what you call a cluster of they have a retail business, they have a PBM business. On each side they have around 90 node cluster, not a huge cluster, but Aetna has 900 nodes out of node cluster. So when we merged, we are getting rid of our PBM, our data, our what do you call our data center. This next year, by next year, we're getting rid of it. We're moving the data to Aetna, and we are also moving some data, advanced analytics use cases. We are moving to Azure because we have Amazon and because they are into pharmacy business. CVS cannot get along. They can't get along with it. And that's a different reason. But what I'm saying, it is cloud, right? So now in terms of course components, we try to completely simplify. We don't want to. If you look at the big data, there are hundreds of products. People get confused, and many people call me, hey, I want to take big data, but there's so many things to learn. I said, no, don't worry about all that stuff. Don't try to learn, Apache this, Apache this. There are 100 Apache something, right? So if you want to learn yourself, yes, you can do that. But we try to focus on the technologies that you can get a job right away. Then learn yourself beyond that if you have to learn, right? One of the things on the big data, I'll go into detail, but primarily we focus on these three areas. One, language expertise. You need some language expertise, no matter whether it's an architect or developer. Without that, surviving will be difficult. Surviving will be okay, but you'll have more confidence. Your growth will be faster if you have a strong in language. So we focus on Python. We cover in 2 weeks, and you can be good in 2 weeks with some practice. It's not a difficult language. We go to the basics and teach it such a way you just understand it. So we'll go into the details of what we teach. Then we cover around 3 to, again, this numbers 2, 3, 4. These things could change based on time. It could go into 8 weeks as well. So big data. After that we cover the big data part. In big data we don't cover everything, but primarily some SDFS. Don't get into MapReduce, those are all gone anyway. We get to Hive because Hive is common everywhere, right? Hive is the database is still Hive EQL, and we get on Spark pretty much. So whatever Python we learn, we use it in Spark, doing PySpark, different use cases. It's easy language to learn if any of you have done, but it's a very powerful language, very powerful language. If you go to cloud, EMR, SD Insight, which we'll talk about, there also you will be using the same platform. I mean, same what you call framework, Spark. So we'll talk more in that talk in detail. So things what we'll be covering in each one of this. Then cloud concept. That's what Vijay comes in. So I covered the Python couple of weeks. Then I cover the big data. Then he's expert on the platform engineering. But we don't teach platform engineering on this side. We teach more how to create use cases, how to move data from S3 to EMR, process it in EMR, then move to Redshift, do reporting. So creating those data pipelines using some of the native components of AWS. But there also you can use those PySpark, HivePL, all that stuff, consuming data from Hive, pushing it to somewhere, right? How to build those pipelines, right? Using this platform. So that's what we'll be covering with some real use cases. So learn the language, learn the big data platform, how to use it on AWS. And if you want to work on premise, you can do that, or if you want to working on the AWS, both will work for you depending on where you want to move. So, but our strategic goal for our company is to go with the cloud way, because we see that is the future. So if we are teaching big data, we are teaching big data on cloud, because although many companies are still doing on premise, but we see that is the future. Let's do that right from the beginning. But you can use either way. It doesn't matter. Any questions so far? Again, these numbers, don't worry, 2, 3, 2, but our goal is to cover language, platform, and big data. This is one stream. The second stream, this is the data engineering stream, by the way, cloud data engineering stream. So two trainings go in parallel. Okay.
So 2 weeks means how many hours?
4 for 8 hours each weekend.
Each weekend 8 hours.
Saturday, Sunday, morning, afternoon, there are some, we'll do that. So yeah, 8 hours, 16 hours sufficient for Python. And big data, it may fall a little bit short, but I think one weekend is sufficient for Python, to tell you truth. Then you will practice. It's not going away. You will come back when Spark comes. You'll come back again Python. So start with something within. I might use 4 weeks for big data. I might, because we'll covering Hive. Hive takes little long time, and Spark. I typically focus those 2 areas. If you learn Python, Hive, and Spark, you will get a job next week. Let me tell you, it's so hard. Right? So you don't need to learn the rest of other things. Just learn how to create tables. The concepts of Hive. Learn a language like Python, then go into the deep of Python, Spark, and you pretty much cover data lake use cases, reporting use cases, AI, ML, all use cases, and even including cloud. Self-study, more. Of course, the more the better. But we do a lot of assignments. It's pretty much lab oriented. We are all industry. We work in the industry, and that's the flavor we bring in. Not just theoretical training and all that. We always bring in the industry specific, use cases and all that. So we try to do more lab oriented. If you just focus on the labs that we do in the class, of course, do the assignments, it should be good. I'll talk about the second part, which is job preparation. There we go even deeper. If you want to be marketed by us, we also do placement and support and all that. That's our vision into the future, and that's what we do. We'll talk about that. That's where we go really deep, and we make you perfect by then. Towards the last 2 weeks, we come back and do that again. Primarily focus on placement, because we know exactly what questions come in the interviews. That's a different preparation, that learning, right? And how to do articulate your projects and all that, how to talk about the use cases, how to talk about similar in syntax, and how do I, so anyway, so there are those things will primarily focus, which we don't do during our training, because that's more regular learning the stuff, right? And the interviews are a little different. That's our goal, and it has been very successful. Whatever has been working in the last few years, we just replicate it. And okay. Quickly, also time check. What time is it? I promised 1 hour. So in the next 15 minutes I'll complete. Then probably maybe 10 minutes. So this is some level of details, but I'll send you the curriculum and all that in a different. I'll email you guys. This doesn't mean that whatever I put here is the everything, but to give you a sense of what I'll be covering. Python language, right? Python development with PyChar, Python data structure and data types, Python class packages, conditional control loop, Python functions, panel. Doesn't mean that that's all, but those are the primary things we'll be covering, so that you know how to write Python programs, right? We stick to the basic and simple structure, so that you will learn it. Any language you want to learn, start with what are the data types are there? How do I simple variable assignment, right? How do I write a loop, if while loop or for loop? How do I do if else conditional statement, right? How to create a method, how to write a package. Any language, if you do this thing, you are good, right? So we sometimes think, hey, language I have to, it's a difficult thing I have to learn. No, just sort it out with in what you call the individual components, and learn it, and then it all comes together to create a program, right? So that's the way we teach, and it's pretty effective that way. What I've seen, the fear factor goes away. What I'm trying to say. Hadoop essentials. That's where we cover all this. Of course, we do some introduction and all that. We cut down a lot of the facts we don't need, because so many stuff is there in the big data. Don't want to cover all those stuff. Pig, all that, they're all gone. Flume, we don't need those. Apache Flink, Apache. There's so many stuff, right? We just cover what we need. Of course, the storage as JVS, and Hive and HiveQL, Scoop little bit, but primarily we focus Hive, Spark. These are the main 2 components apart from Python. Yes, we do cover Scoop little bit, Kafka little bit, NoSQL little bit, so that you have a flavor to know what they are. But for your job, to get to the job market, which is our goal, your goal as well, we want to focus on Hive and Spark. We go deep, so that you really make mastery on it, and then you can handle the interview questions and even some level of work, right? Data ingestion and processing use cases. Okay, once we do that, then we come to okay, this is did we add the cloud part? Maybe can I do that? Next slide. Oh, here. Okay. Yes. So, and as we cover those, we also cover some of those ingestion. We do a project, we do several projects anyway, but you know, covering how we build the data mart in Hive, concept of fact table, what is dimension table, things like those things, right? Data ingestion using Scoop, how do we do the data ingest? Data processing with Spark, right? We have a lot of use cases doing that. And some real-time integration with Spark streaming and Kafka. Those are not really important, but we'll give a flavor of it. Right? You can't be expert on everything. We don't want you to make. We don't want you to make you expert. That then you get completely confused. Rather, focus on few things and be good at it, and get the job. Then you go and learn other things. Because by that time you will have the foundation. You can learn yourself. So anyway. So that's kind of things we cover in the one part. The second then concept, the cloud part again. We come in, and that's where BJ will cover this different storage on AWS and some of those concepts here. Redshift is the database, right? OLAP database on AWS. Snowflake is another database, right? RDS is some databases, and there are some other functions, Lambda function, is that, right? So and when you put it all together, it becomes what you call several use cases, right? That's what ingestion scenarios. As I said, your data lake, you create an S3, move the data to EMR, do the processing, make the data ready for reporting, push it to the Redshift, do reporting. Right? Typical data pipeline building. So that's what we'll be doing once you know the components. Here we don't go deep into platform engineering. That's a different course. Automation, all that stuff, that's different. You don't want to learn everything together, right? But some people don't like programming. They can go to the platform engineering and they can still excel. There are huge demand in those areas as well. So anyway, we just want to separate, but the people also sometimes take both sides one after another. Okay. Any questions so far? So as I said, I kind of want to summarize it. We learn the basics of Python or the language. We deep dive into the Hadoop components like Hive, Spark, primarily those two. Others also we cover, and we cover some of the use cases. Then we come to last 2-3 weeks. We cover more cloud-based use cases with cloud storage. What is S3? What is EC2? What is Redshift? What is and what is EMR? Then how do I put this learnings Python Spark into a use case there, right? So that's the kind of goal. Any questions over? That's our course curriculum.
Yes, I have a question regarding the certification. So
yeah.
Is it going to be the Cloudera Hadoop certification, or is it going to be the AWS Bigdata certification?
Good question. So big data, if you want to go for big data certification, yes, you can go for Cloudera specific or Hortonworks specific certification. There is a Spark engineer Spark certification. I think it's CC 175. I had so many students who was passed that. Whatever we'll teach in the class, Spark, Hive, and all that, you will be able to pass that. You will be able to clear that. Around 12 to 13 questions, 70% those are actual situational questions. We'll cover those, and you should be able to clear. Other side, you can do the big data specialization with AWS. If you focus on the cloud platform, there is a whole the cloud practitioner, associate, architect, professional. You can pick your specialization. Security, there is one big data specialist, and but I am not done that. I am doing it myself this year. Although so yeah, just again, just to get those certifications, sometimes it helps. So yes, those you can go with either AWS, so that you have the platform as well as AWS Big Data, right? You can do those special, or you can go with vendor specific, as in Cloudera specific certification as well. What we teach here will prepare you for that. Okay. Then I'm just giving you a little bit of job enablement program. This is our focus. We teach folks so that they will get the job, not just for training, and that's why you focus on and also do marketing and all that stuff on job support as well. So this is where interview preparation. We have been training and placing people for many years, and we have both of us we have been taking interviews almost. When I was with Infosys, almost every day I was taking few big data interviews. I'm not with them now, but that's so we know what the industry needs, and based on that we can teach you how to prepare for the interviews, right? Sometimes learning and interview are completely different, right? Mock-up sessions with extensive question banks, scenario testing, right? What if this is this? What happens, right? Your query is running slow. What do you do? Your Spark memory, it's out of memory. What do you do, right? What are the parameters you can change to get out of out of memory error, right? Those kind of stuff. Performance issues, right? Because we are bringing those knowledge from our real work. Okay. Project articulation. How do you articulate the project, right? That's where we help. If you don't have a how to project big data project, how to make it a big data project, and if there's something goes on, but as long as you are confident, you can express it. There are not many resources in the market. Companies need people, right? So if we can do that, we are doing a favor, I would say. So anyway, marketing, of course, we do dedicated marketing for the people. Coaching for interviews. If you are go with us, hey, tomorrow I have an interview. We coach. Okay, this is the requirement. We coach you. This is how we answer, because interview is different, right? Requirement is different, so maybe a little bit of twist. So we do that, and this is again from our learning in last 3 years how we have done with other 25-30 folks. Review with interview feedback, corrections, so those things. Hey, I got these questions. Let's review it. I couldn't answer this. So this is a live help, and we do that throughout the week. We put a lot of hours, lot of interest for people's and folks' success. We know their success is our success. That's what we have built, and we will continue building that. Of course, then placement, right? Technical support, ongoing, all that stuff. If you are going to the job just with learning, you need support, because you just cleared the interview, you haven't worked, right? So you need support. We know that, and that's where we will come and provide support as a part of the package. So that's we are planning to start August 7th, 17th. We have still earlier we are thinking of starting first week, 2 weeks. We still have the current batch is still getting delayed. So, and weekends, and there are, for example, weekdays I put like for the cloud, we have a touch-up session every Friday, Wednesday. Whatever lab work we do over the weekend, there's 1 hour touch-up. Hey, who couldn't do it? BJ does that. Okay, let's look at your screen. Where you couldn't do that, right? Let's look at that. So we have touch-up session to help you to finish those assignments. But anyway, and any questions so far? So that's kind of, I don't want to go into the details, but I would rather cover the curriculum. We talked about the market needs, what the industry needs, what are the key areas you should focus to be successful, right? And how does it look for next 10 years? Are we in the right field, right? We kind of talked about that. And 2 streams, I just covered the data engineering. Now Vijay will talk about the platform engineering side. Okay.
I have one last question.
Yeah.
What kind of data will we be dealing with? Is it structured or unstructured?
Good question. So question is, what kind of data we'll be dealing with, structured or unstructured? Even in industry, still there are 90% of the data is still structured. We now talk about unstructured and text analytics and all that. In fact, that's what I do most on my side. Text analytics, NLP, natural language processing. That's my last 2 years of work on my side. But I would say, to get into the job market, focus on structure for now, because your things will get very complex, and you'll look at many different libraries on NLP side. I can talk about 10 different libraries. I'm experimenting with one Google library called BERT, bidirectional something. Anyway, so it will get complex. Text analytics, you will get into AI and all that stuff. Okay, but if you look at just purely data ingestion and processing standpoint, yes, we deal with JSON file, XML file, those kind of delimited file, right? Those we deal with. But for analytics standpoint, that becomes a completely different subject. You are getting into text analytics, text mining, AI around that, getting the sentiments, emotion, intent out of that, right? That becomes a completely different subject. You want to learn? Talk to me later, because that's my specialization. But again, 90% of the data is still structured. People are still dealing with the data marts, data, right? Creating reports, AI, ML, they are still based on structure, 90% data. But slowly, as you said, you're right question, the unstructured data is coming in next 10 years. Yes, you will see that. There is special interest, we can look at that. But is it? I'm sorry?
So most of the tools that we see, like how we must see the website, it all seems like no simple.
Yeah.
Structured. You're not covering everyone of the structured database.
Okay, we are saying we are not covering any structured database. Of course, Hive is one of them, right?
Hive is a data warehouse.
Data warehouse, yes. Yeah. So we are covering HBase, as part of the what you call Hadoop ecosystem. The reason I'm not getting into Cassandra, it's a huge topic. I used to teach Cassandra separately. In Newman Marcus, they used to have Cassandra. Did consulting with them 2 years back through Infosys. When I went there, did some presentation, and Cassandra is a very complex database. I was a Oracle DB. It's like it's very lot of tweaking you could do. If you just want to learn Cassandra, it will take 3-4 weeks. Let me tell you, it's pretty comprehensive. But that will be a subject by itself. And there is a data stacks company which is specialized on the whole thing. But if you want to just a flavor of it, learn HBase or some of which are very quicker. But you get a flavor of it, how it is. Right? What is columnar storage? Is that some concept? But if you want to really be expert on it, then we are talking about another 4 weeks. So that's the reason we focus on more on the data reporting, those which are common use cases, just to get you up the ground and get started. But we did, so that's a good point. Maybe dynamically we can cover on the side. I don't know.
No, see, the objective here to focus on the data engineering part. Okay. So this NoSQL or in-memory database like Couchbase, these are all kind of a consumption thing, right? You don't need to have a dedicated architectural experience in that. As a data engineer, what do you do? Hey, what are the libraries should I use? What are the parameters in Spark should be tuned so that you can process millions of records maybe in 10 minutes. So those are the use cases which we are facing. Where Cassandra, once you design the database, everything, once you create the tables and all, done.
Not in the architectural point of view of database,
Mhm.
but once you extract and do transformations, then load,
Yeah.
the loading portion should be done in database. That's
Correct.
the way that perspective probably we should be able to have the conversation.
Spark connectors are there. There are Spark connected to Snowflake, Redshift, Couchbase, Cassandra. As we speak, I'm doing the major transformation of the complete ecosystem. Same Neiman Marcus. I'm moving to cloud now. Okay, so we are using
A little louder.
yeah, we are using 3 layers on-prem. They're going to advanced analytics, customer experience layer, and the data warehouse. The data warehouse is in Vertigo. Advanced analytics in Cloudera. The CXP layer is comprised of Couchbase, Cassandra, Solar, and we have Jetty server for the API gateway and all. So we are migrating everything to cloud. So there are a lot of projects like this. The on-prem, your data platform is moved to cloud. Here, Cassandra on-prem, Cassandra AWS, exactly same, no difference. So just a lift and shift. What is changing is the data ingestion part. That is not changing. Then there are a lot of connectors available in Spark itself. The Cassandra, Couchbase, Snowflake. Snowflake is a commonly used cloud data warehouse system. Whether AWS or Azure, they have their flavors. So the point here is data engineering. The topics we are covering here primarily meant at data engineering, where there's a lot of opportunities. Myself, I am interviewing almost every other day for these kind of skills. We don't get that.
Basically, ETL skills.
I would say ETL is extract, transform, load, right? Now that is changed. It's a data ingestion now. It will be real time, batches, micro batches. These are 3 prominent data ingestion patterns. And everything is decoupled now. Storage itself, it is not a single storage. You have primary data lake sitting in S3 or in AWS. If it is Azure, it is blob. That's primary thing. And based on the need, we will generate different kinds of file formats: RK file, ORC file, CSV files. And not only the performance, there are other use cases. For example, in most cases, you're loading say 1 million records. There will be 10 bad records. What do you do? So we define a rule. Hey, if it is only 10 records or 100 records, load them to a S3 bucket or table for future reference, go with the rest of the data. So this kind of setting a threshold value will work only for CS3, not for Parquet. Okay. So these kind of industry experience we bring on board during our session. So as I said, it may not be 2 weeks, 3 weeks, it can span across. So net, data engineering is the key here. Regardless of your data storage, how seamlessly you can build your data ingestion layer using Spark.
Primarily Spark with as a process unit, or even ingestion itself. Spark also serves as ingestion.
Data ingestion we use Scoop, right? If it is
Not really.
Scoop you use
data bits, just
no.
the Scoop to
Scoop, what you do, extract from the mainframe and dump into your S3 or Hadoop, any distributed file system, right? What do you do after that?
So then the next is ETL, the transformation or cleansing the data that all comes as part of the Spark, right?
Correct. So the way you load data into say Redshift database is different to Couchbase, different to Cassandra. Those kind of things will be covered. Not the administration and the architecture of Cassandra or Couchbase. That we don't do that.
All right, so that's data engineering side. I'll quickly, what time it is? So quickly, 10 more minutes, maybe 10, 15, we can go ahead and cover. Where is it? Is it this one?
Yes.
This one?
Yeah.
Yeah, quickly. I know now the people have got a flavor at least, so we don't have to go into detail. So go ahead. So folks, now Vijay Ramchandran, he's our AWS guru here. So he will talk about the platform engineering side with the second track. As I said in the beginning, we have two tracks. One is AWS platform engineering, other one is data engineering. We started with data engineering. We should have started with platform, that's okay. And now he'll talk about the platform engineering. If you go with that track, what do we learn? Okay. And what's the market demand, or why should we learn?
Right? Hello everyone, thanks for joining. So this both the programs, cloud platform engineering, cloud data engineering, is a really customized, tailored course with specific goals. It is not that hey, we give you a lot of theoretical knowledge and leave you. No, the objective is to transform experienced IT professionals and graduate engineers to be an efficient platform engineer or architect. That's the objective. It is not that hey, we give some lot of PDF documents, some YouTube videos, and all. No. We make sure that you understand the concept very well. So it is a typical transformation, right? Till today we are working on, hey, there's a couple of servers, you do some code or drag and drop using Informatica and all. That's not the case in cloud. So you should understand the key concepts. What is networking? How the communication between your laptop sitting here talks to a server sitting in Palo Alto or Google's server, when you say google.com. All these communications, how do you optimally build your solution scalable? One of the keyword you keep hearing is elastic in nature. For example, every Monday, first Monday every month, there is a sudden spike of the load. Only for that 1 day or 4 hours, I need a huge server. In an on-prem, it's not possible, right? You have to buy a server. There's a 6 weeks lead time for procuring and all. After that, what do you do with that? Here, just click. You can provision automatically, run for 6 hours, shut it down. Okay. So here you'll prepare the foundation cloud technology, which encompasses networking knowledge, OS level knowledge, and what is cloud, with lot of real-time lab exercise. Okay. There are 90 plus services. As on 2 weeks or last month, now there are 100 plus services in AWS. They are bringing every day, but we don't use that all the time, right? So there are, for any project, there are 20 plus vital services which must be there for any data lake implementation or a ML based application, or could be data science activities, data exploration. Now there are some 20 services which is a must. Otherwise, the things will not work. We'll take a deep dive into most commonly used vital services. Okay. So I have more than 22 experience in the IT industry, worked in India, of course, UK and Central Europe and the US. Specialized in the DevOps, big data technologies, working as a senior solution architect for Infosys. Apart from my regular projects, I'm also a key contributor in the Cloud Center of Excellence. So I have to build a team based on the market demand, and I'm also part of the business expansion for my company in the cloud space. Okay, I worked in multiple domains so far. So just to give a heads up on the what are different kinds of cloud offerings, how they are increasing year by year. Okay, so there's at least 40% increase, right, every year. 20%. Yeah, 130% increase every year. Okay, it's much more higher. So we'll be focusing on these two areas.
PaaS and SaaS.
Yeah, PaaS and SaaS and delivery of this one. We don't get into these things in detail. This is totally different area. Compliances, security layer, firewall kind of thing. We don't get into those things. Okay. Just to give a heads up, what kind of salary expectation, if you know the best of both cloud and big data. Okay. So the hiring skill is 78 jobs, which are in the market for more than a month or 45 days. Even for my company, I'm interviewing people. I don't get good people in the market. Every day there is at least a couple of interviews, sometimes more than 5 interviews a day over the weekends, but we don't get people. So I can get a lot of people who are certified. I was talking to one guy 2 days ago. He is AWS professional certified, which I'm not, but he didn't know the basics. Theoretically, he knows everything, but I give a use case. Hey, how do I spin up say 100 servers without any manual intervention? This is a very common thing we do that. The answer is nothing but platform automation or cloud formation template. You create one template on 100 times, your service is ready in say 5 minutes. So unless you do things you won't know. They'll say cloud formation is used for platform automation. Take, you got one part. But when it comes to the real work, that's not the case, right? So a lot of things. For example, in cloud, when you shut down a cluster server, you lose the IP address, right? But I want to have the same IP address all the time. How do I do that?
Elastic.
That's expensive. I want to have static IP. How do I do that? The answer is ENI, Elastic Network Interface. That you can define hundreds of thousands. That is within your thing on. Elastic IP is exposed to internet. That is chargeable. Okay, this is within your system. You can have hundreds of ENIs. And there is a way to make a reference as part of your CFT. These are too much detail. But my point is, our course is not aimed at teaching you all the theoretical things. We can take a deep dive into EC2, for example. We'll cover everything. It's focus on 15 to 20 services. We'll teach everything in detail, which are needed for the your work, not for any academical things. Okay. So, yeah, it's a nice pictorial representation of cloud. Regardless of the kind of devices you use, cell phone, iPad, actual computer, or the servers, everything will be stored in the cloud. Cloud is nothing but an extended data center maintained by AWS or Azure. Okay, you can say that. So, what's the difference? AWS has tens of thousands of servers in a village, I would say. It's a server village. Okay, so they are able to scale indefinitely, and these numbers are increasing day by day. Okay, so we'll take a deep dive into what is cloud. So I'm about to finish for my first batch. I think they are very clear about what is a cloud, what's the different cloud offerings, what is networking. When you say www.google.com from your laptop, what is happening behind the screen? They know that concept very clear. Okay. Then only you can define a VPC. Then only you can define a subnet. Then only you can define a firewall called security groups. All this will be covered in detail. Okay. I like this analogy. What's the difference between cloud and other thing? Owning a private car versus renting a car. If you want to drive a Ferrari for 2 days, you don't buy that, right? Just rent it. Okay. So we'll take a deep dive into conceptually what is SaaS, what is platform as a service, what is infrastructure service. So we'll be covering most of the things. Typical software as a service is salesforce.com, right? You just use that. You don't know what is happening, but you don't manage the server. You don't take a backup. Everything is available for you. It is completely managed by the Salesforce itself. Okay. What is platform as a service? I would say easy to instance. It's a platform maintained by server. You have a server, you maintain everything. When it goes down, how do you take it back? When you lose data, how do you recover back? All these are covered under platform as a service. These will go hand in hand, platform and infrastructure as a service. If a custom built solution is sitting in an EC2 instance, that is platform as a service. The consumer will not know that what you are doing, but you maintain that. Infrastructure is a vanilla kind of thing. Okay, you can spin up whatever instance you need, you maintain everything for the data ingestion, for example. Or Cloudera cluster, you're spinning up in AWS, you maintain that, right? Whereas Cloudera itself offers a, what is the name? Cloudera, they have a cloud version, pay as you go. Okay, in cloud, in AWS, there is a service called EMR, that is Hadoop cluster. Okay, so they're fully managed by AWS itself, and it also enables the auto scaling. So we can define how many task nodes or data nodes should be there. Based on the workload, it automatically increase. You can define, hey, whenever there are 50 Spark jobs are in a pending state, you spin up a new one. So it automatically spins up. When there is no activity for say 3 minutes or 5 minutes, it just terminates automatically. So it will be seamless for the users. So we will cover what is auto scaling, how to implement that, not only EMR but also in the EC2 instances. Whenever there is a cluster of EC2 instances servers, the auto scaling will be used. Okay. So what is assured? Strong foundation to succeed as a cloud engineer, platform engineer or architect. With on focused on the industry needs. Industry doesn't need all the 90 services. Need only 15-20 services that we will teach you. So many people don't know how to define an IP address range for a subnet. Someone is saying what is CIDR range, they don't know. I ask these questions in their way, hey, do you know what is CIDR? They say I heard, but I don't know. So without knowing CIDR range, you cannot define a platform, right? So you'll be very confident in the concept. You can explain very clearly, and we are all there to support you whenever there is a need. And we have one more partner, as RP mentioned, who is a solution architect working with AWS. Yeah, Amazon. Okay, he's full-time employee. So he's sharing a lot of his experience. He's certified in all the AWS. So we'll guidance to get certified.
Takes a class purely on certificate somehow.
Yeah.
You get also discount, 50% discount from the certificate. You get his special.
Okay, so we'll be covering the second and third columns. Networking fundamentals, as I said, when you type something, what is happening behind the screen? We talk about the range, what is a DNS, what is an on-prem network architecture, how it is being translated to the cloud architecture, what are different types of protocols and IP addresses, how to define subnets, how to choose the right, how many subnets you need based on the application. All these things will be covered in detail. We take a deep dive into these concepts and how it is being implemented in the AWS.
Just to make sure online folks, if you have any question, please do.
Yeah, feel free to stop me anytime.
Yeah.
Okay.
And being a recording of this demo session, I am going to share with everybody anyway.
So we'll be without knowing the at least basics of Linux, OS, and all, you'll not be able to spin up any students. So we'll be teaching you basic things, but very critical. What is a file system? How to add a file system to a server. For example, in cloud space, everything is decoupled. Your processing is decoupled. Your storage is decoupled. EBS volume is a storage component, right? So when you define a EC2 instance, say you are spinning up, say minimum 8 gig root volume. But if you want to add say 100 gig, how do you do that? How do you attach and detach? A machine goes down. How do you recover the data? Store the EBS volume. So we'll have a deep dive into these kind of things. We will also cover the recovery will be covered in detail. For example, alerts and monitoring. If instance goes down, you should be informed to support immediately. How do you do that? What is SNS? It's a notification service. How do you define the CloudWatch events? When machine goes down, what to do? We'll cover Lambda. We'll have a little bit of DevOps and platform automation. We'll cover in detail. Okay. Parameterized using console, using the CLI commands. We'll cover in detail how an actual CFT is built in a real-time production environment. We'll teach in detail.
Platform automation, cover all of those, CFT, Terraform, all of them, or just one of them?
Well, we'll definitely cover CFT, AWS documents. Those two will definitely cover. Based on the time, we'll go for Terraform, Sector, and all. Based on the time, because you don't get time to cover everything. But we will see how to approach that. Once you know CFT, Terraform is simpler version of CFT. I would say that. Okay. What else? Then we'll get some bit of cloud database systems. Redshift, Aurora, RDS, Snowflake. We'll cover those things in detail. Whatever is needed, not the architecture level, but how it is being set up. Then security. How do you define roles, users, group, security policies? How do you restrict your access to various people? Those things will be covered. I think these are the things we do in our real projects. So we'll get a deep insight to all these areas.
Python,
Platform engineering side, you don't need to know Python. It will definitely help. When you write a Lambda function or it will help you. As a platform engineer, what you really need is shell script, little bit of shell script, then networking knowledge, Linux knowledge, admin knowledge, then deep understanding about the various services, what to use, when to use. For example, if you have a cluster, take Informatica cluster. So for the high availability, we have at least 2 or 3 Informatica servers. But all the system files, log files, config files should be shared across all the 3. Then only if one goes down, others can spin up immediately. And further, what we do is something called elastic file system. So n number of servers can point to same set of folders and access at the same time. Of course, if there are more access, more number of servers, there could be an issue with the performance. But architecturally, it supports everything. So these kind of things we really do in our day-to-day life. We'll teach that. Storage gateway. That is one of the commonly used whenever the business users are involved. You know, a typical business user for using Tableau and all, they used to just drag and drop to some shared location. That's why available in Tableau. In the cloud, how do you do that? From laptop, you drag and drop should be available in the cloud. We use storage gateway. So these kind of typical business use cases will cover in detail. So there are another hundreds of services, we are not going to use that. But this will help you to build on top of. For example, when you go to your work, join a project, they are using SageMaker. You'll easily know how to integrate the SageMaker and start build on that. They will say, hey, I need to configure S3 bucket. For the SageMaker, you can take data, run the algorithm, and put the output back to the S3 bucket. No, these kind of things you can do very easily.
Just in the interest of time, maybe
Yeah,
try to
I
finish in
think
5 minutes. So, sorry, folks, we are stressed a little bit. 10 minutes.
Yeah, that's it. We will cover these 2 streams.
So as so Vijay kind of explained his curriculum. Hope you have any
questions?
Questions, let us know.
I know there's too many things to chew at the same time. Still.
So, but again, summary again, if I want to summarize, there are two streams, as I said, but both are AWS specific. Although it is big data, we want to make it AWS specific because that's where the value comes. But if you want to go and apply for on-premise, somebody has cloud, you can still do that. Not a big deal. But if you are looking for what carrier in cloud down the road, that will help. You learn the Hadoop, you learn the big data, the essentials of big data basics, which is your Hadoop, Hive, Spark, Python. You can use it either in cloud or on-premise. It's totally up to you, right? But and in the platform engineering, which is all about how to spin up things, how to manage elastic nature of all that stuff, recovery, backup, all that stuff, right? That primarily more focused on the platform side. On the other side is more how to manage data. If you ask me which one is good and better, right? Of course, if you ask me, data engineering is more value. Because anytime you would bring data into the picture, you elevate your stature, right? So but that being said, platform engineering is hard too. I mean, there are not people who know this concept, and there are so many migrations happening, so many companies are going in, and there need a platform engineers. And you don't like programming something, Python, this, that, yeah, definitely you can stick with so giving you two options, or you can go with both, one after other. Don't do it parallel, one after another, right? And get certified and get ready, right? Basically next 5-10 years, whatever, right? At least 5 years, your kind of career is set, I would say. So that's what I would say.
So, oh, sorry.
No, go ahead.
So at the end of the 8 weeks, we will know the big data side and the platform engineering side.
No, not both. You will not know. If you are going on the platform engineering side, you are not knowing big data side, okay, because they're run in parallel. If you are going on the data engineering side, you are knowing learning Python. In Python class, we allow both the batches to sit together so that they can also learn. Okay. But we on the data engineering side, we instead of going details into the platform side, what is the PPC, all that stuff, we don't go over that. Assuming the data is there, what do we do in terms of data ingestion and processing? That's what we focus on the data engineering side. Bring the data from EC2 to this, right? AMR, process it using your Spark code, and push it to Redshift or Snowflake and do reporting, or AML, those kind of stuff. So little bit different. As you see here, any details on the financial requirement? Financial requirements. Okay.
Yeah, the pricing.
Oh, that we'll talk about. Okay, that we'll talk. Is it Michael? I think, right? We'll talk in the. We just 15K. No, I'm just kidding. So if you go and do this trainings with the AWS, 3 days training, they'll do both the PPT and all. They'll charge you $5,000 or $3,000 typically, right? Crash course 3 days, you won't learn anything, but you will have good PPTs and all that. But here this is stressed across 6 to 7 weeks, so you can kind of soak in the stuff, right, slowly, right? And that's how it is built. And as I said, we bring the industry knowledge, and we are also working on enterprise architect in our place. I do Spark stuff almost every day. I see the problems, and we will bring that knowledge and experience to you. At the end, you guys, you are looking for a job, and that's what we try to make you successful. So that's our goal, and as I said, I believe we do it passionately, and that's what we do. I've been doing that. So get in touch with me. We still have 2.5 weeks to go, but we'll get you enrolled. If let me, we can discuss which course, which one you want to go first, based on your skill set. I can advise. And again, it's not the end of the day. If you can't do big data right now, get the platform engineering done. Then if you want to, then you do the big data, right? That can also happen. Eventually, probably you need to know the both if you want to really expert in this area, right? As I said, cloud is the platform of future. Why shouldn't I be expert in this area, which will build my future for our career for next few years, right? So anyway, do call me, do talk to me, and we'll talk. We have couple of weeks to go, so we can have discussion on that. I won't take a lot of more time. Please, any other questions online, folks? Yes, please. Is that Amit?
Yeah. So I have one question. Like,
you can speak up.
Yeah, can you hear me?
Yeah, please go ahead.
Yeah, can you hear me?
I can't hear you. Is that Amit?
Yeah, this is Amit. Can you hear me?
Or please go ahead and type in the chat.
Okay.
Right. Okay. Call me, Amit, if you have any question. I think it's Amit. So do call me, or whoever it is, please call me. We can talk. Don't
Yeah,
want to take a lot of your time. If you don't have any other
can you hear
questions,
me?
I will end the demonstrations right here. I can go ahead and share the videos if I have your email addresses. If not, please do provide me. And me and Visa will be available for next, couple of weeks. If you have any questions to make a decision, which way to go and all that, do talk to us. So we'll get started probably in the mid August. So we'll go from there. Okay. Thank you so much. Thank you so
Thanks
much.
for joining.
Thank you.
Thank you.
Thank you, Gayatri, Jaya, Michael,
Thank you.
and
Thank you, Radhika.
okay. And Suresh, thank you as well.
Thank you.
Amit and others. Okay.
Yeah.
Thank you. Let's get in touch with me later on. Okay.
Sure,
Thank you.
I'll call you. Thanks.
Thanks, Satyakam. Thanks, Vijay.
Stop the recording.